Hello guys, today we are going to see the binary tree pre-order traversal. So it is quite clear what the statement is. So it says that recursive solution is trivial. Could you do it iteratively? So just for the sake of it, I have provided the my iterative recursive solution. You can go through this code if you would like to. You can pause here and look at it. So instead of looking at this recursive code, we can go ahead with the iterative one. But before that, I would like to mention like a small detail about this traversals. So if you see in my previous video, I mentioned the pre-order, in order, and post-order traversals sequence. So it goes similar to that. When you are doing a recursive pre-order traversal, this is the sequence. Like if you are very new to this, you can remember it like this. If it is pre-order, before going to node.left or node.right, you just perform whatever you want to perform before those two recursions. That is pre-order. When you are doing in order, this whatever the procedure you want to do will be in the middle of these traversals. In post order, it will be at the end. So you can keep that, and this a little like short tip. So let's go ahead with the iterative solution. Now you can comment this out. If you're new to Leetcode or programming in general, you can comment this out by using command and forward slash key, or in Windows it should be control plus forward slash. So let's go. So you can we can do this pre-order traversal using a stack for iterative solution. First, okay. So first of all, we will check if root is not none. If not root, that means we have been sent an empty, like empty tree. We just return empty array. That's it. Now we will initialize the stack with root in it. Then we will take response array. We can do one thing. This is a response, as in the result that we are going to return. It should be initialized with empty array or list. In Python we call list, but that's okay. So what we'll do is while stack, or you can write it as while stack is not none. That will also work, or stack not equal to empty array. Then we will go while stack. We will pop up the last element into the stack. You might already know that stack will work as first in last out resource. So whatever we put in the first, we can get it out at the end of iteration. So since we are just started with single node, it will first pick up pick up the root node only. Later we can look into it in more details. Stack.pop. So we will get the root. Now here comes the tricky part. Before that, we will just, since it is a pre-order traversal, we will append this node's value to the response. Now here is the tricky part, that since we want to do a pre-order traversal suggests that we will first visit the root node, then its left subtree, and then its right subtree. So as I mentioned earlier, it's a stack. What we will do is we will append the right subtree first. What will that achieve is, if we append the right subtree first in the stack, then we will append the left subtree node, that is the left node. Now when we go back in this loop, we will be popping up the left node first. That way we are maintaining the NLR rule for pre-order. So it will go like this. If no, and we also have to check if the node on the right and node on the left are there. If not, we don't have to append a none. the on it, otherwise it will fail here if you just appended a null node. So node dot, if node dot write, we will do stack dot append node dot write now, and we will also check for similarly for node dot left. If node dot left, we will do stack dot append node dot left, and it's done. Now we will just return the rest. We should be good here now. Let's see. Yeah, it's accepted. For some reason the run code didn't work properly, but it's done. This is the code for pre-order traversal. If you, okay, thank you guys.